Welcome back, ladies and gentlemen. Today, for this week, we're going to be talking about section 7.4 and 7.7. For right now, I'm skipping 7.5 and 7.6. We're going to be doing 7.5 next week, and that'll be the last thing that we do for the semester. So yes, the end is in sight, but, well, just because it's sight doesn't mean that we're there yet. Okay, so 7.4, what we're going to be talking about, we are going to be talking about how to solve polynomial equations in factored form, okay? So factoring is where it's the inverse of multiplying, okay? So factored form, we're going to have the polynomial broken up so that way we can solve them, okay? The main thing that we look for, as long as we have a variable to the first power, we can solve these, all right? So that's the entire point of this. We're going to be given different parts for 7.4, and then we're going to solve each of these. Okay? There can be multiple answers to these. There can be no answers. Big thing is, as long as we're paying attention, doing our stuff, we can solve them. So the first thing we're going to talk about example 1 and example 2 here. Now, in order to solve these, okay, first and foremost, they have to be equal to 0. If they're not equal to 0, then we have issues. Fortunately, everything that we're going to be doing today will be equal to 0. Now, since these are equal to 0, all this is equal to 0, basically what we do, we set both parts equal to 0. So I got this first part that's outside the parentheses equal to 0, x equals 0. If we had to solve for x, it's already done. We don't have to do it. Boom, that's one of our answers. Over here, the part inside the parentheses becomes something. So now we have x minus 1 equals 0. Well, to solve for x, you add the 1. X equals 1. So guess what? Right there and right there are our answers. So to the equation x times the quantity of x minus 1 equals 0, you set them both equal to 0, so x equals 0 and x equals 1. If you were to plug them back in, you get 0 times negative 1. Does that equal 0? Yep. Plug in 1, you get 1 times, well, 1 minus 1 is 0. 1 times 0, is that 0? Yep. So that's how you do it. So now let's look at this bottom one. It's a little bit more interesting. Again, we have two parts, so let's set them both equal to 0. So we have 3m equals 0, and m plus 18 equals 0. Well, to solve for m, you divide by 3. 0 divided by 3, m equals 0. Okay. Plug it in. 0 times 3 is 0. 0 plus 18 is 18. 0 times 18 is 0. Perfect. Let's solve this one. Well, minus 18. Two different answers. They both work. Okay. So this is how we would solve them if we have a variable or something on the outside of the parentheses and a variable or something and a binomial inside the parentheses. Okay? Now, sometimes they're going to mix it up on us. So we're going to do example 3 and example 4. Okay? Give me a second here. All right. Example 3 should look very familiar. Well, somewhat familiar. 5y minus 4 times 5y plus 4 equals 0. That's an awful y. Okay. To solve this, it's like solving the other ones. We have two different parts. It's just this time instead of a monomial and a binomial, they're both binomials. So we set them both equal to 0. Oh, that's plus 4. Okay. Now we solve for y. Subtract the 4. We have 5y equals negative 4. Divide by 5. Wait, why did I subtract 4? It's supposed to be plus 4. We cannot reduce that, so y is equal to 4/5. You can get fractions for answers. That is fine. Or it could be a decimal. 4 divided by 5 is 0.8. Now we're going to do the same thing over here, except for this time we really are going to minus 4. So you get 5y equals negative 4. Divide by 5. Y is equal to negative 4/5. Both of these are our answers. They just happen to be opposites. Okay? So when you have two binomials, you may have to do multiple steps, but you still set them both equal to 0. Okay. For the next one, slightly different, but the process still works the same. So we have 2k minus 11 squared equals 0. Now to talk about what this squared means times itself. So technically, this is 2k minus 11 times 2k minus 11 equals 0. Two binomials, we need to have two equations. 2k minus 11 equals 0, and 2k minus 11 equals 0. These are the same thing, so all we have to do is solve one of them. Add 11. 2k equals 11. Divide by 2. K is equal to 11 halves is your answer. Even if we were to solve this out, it'd be the same thing. So anytime you have a squared here, that just means you solve the part on the inside of the parentheses. Okay? Now the last one for this section is going to have multiple, so it's not just going to be two of them. There can be more than two. Heck, there can be as many as I want there to be. But I'm not that mean. This time we're going to have three parts to it. X minus 8 times x plus 5 times 3x plus 18 equals 0. Three binomials, three parts. We're going to have three answers. Set each part equal to 0. Now we solve for x. I'm going to add 8. Eight is one of our answers. Over here, I'm going to subtract 5. Negative 5 is one of our answers. Down here, we have multiple steps. I'm going to subtract 18. 3x equals negative 18. Now I'm going to divide by 3. Negative 18 divided by 3 is negative 6. So for this one here, we have three different answers. 8, negative 5, and negative 6. Sometimes they'll do that to you. You could also add an x out in front here. So let's say we had 24x out in front. Well, that's just another part. 24x equals 0, divided by 24. Then we'd add an extra answer of 0. This is all perfectly fine. You just set each part equal to 0 and then solve. And that's it for 7-4. Next, we're going to talk about 7-7, but while I'm getting this all prepped, here's your random question of the day for extra credit. What has been one thing that you have enjoyed about my class so far? Doesn't necessarily mean like right now. I'm just saying things that I've done in class that you have enjoyed. Go ahead and email me your response, and I'll give you extra credit. Okay. Now for 7-7, we're going to be doing a part of this. My goal, I want us to be able to factor. So factoring is the opposite of multiplying. It's splitting it up. We're going to be doing it for a special case today. Okay? We're going to be looking for the difference of squares. There are 3 things that allow us to do it. So, the first thing, there has to be 2 terms. Second thing, one of the terms have to be positive, one of them has to be negative. And then the last thing we look for is we can square root both terms. Now let's just take a look to see what that means. So we're going to do example 1 here real quick. We have x squared minus 16 and I want to factor it. So we look for our situations. Do we have 2 terms? Yes. This is positive, minus in between, which means this is negative. Okay. Do we know the square root of x squared? Well, if you square root a square, it's just the number. So yes, the square root of x squared is x. Square root of 16 is 4. So this is what the difference of perfect squares allows us to do. We're going to be able to rewrite this as 2 binomials. The first term in each binomial is the square root of our first term, x and x. The second term is going to be the square root of our second term. Square root of 16 is 4. Since this is positive, this is negative, what that means is that we're going to have one that's going to be plus 4 and one that's going to be minus 4. So our answer then would be the quantity of x plus 4 times the quantity of x minus 4. Now I'm going to double check this. This is what I'd be looking for an answer. That would be your answer. I want to show you that this is the case. So I'm going to distribute my stuff through. So I'm going to distribute this x through. X times x is x squared. X times negative 4 is minus 4x. Positive 4 times x is plus 4x. Positive 4 times negative 4, negative 16. Now look what happens. Gone. And what are we left with? Our original. So with factoring, we are looking to change it from this binomial here where we have a squared, we can square root both of these and it's minus in between, into 2 separate binomials. This one was one of the nicer ones that you'll run into. We're going to get into some of the more interesting ones. So next up, let's make it more fun. 4y squared minus 225. So let's check for our stipulations. 2 terms. Yes. There are only 2 terms. 1 positive, 1 negative. Yes. Next thing. Square root of 4y squared. Well, the square root of 4 is 2. The square root of y squared is y, so we know that. Square root of 225 is 15. We know that. So we are good to go. First term, square root of this. That was 2y. That's going to be 2y. 225 is 15. We want one that is plus and one that is minus. Right there's our answer. 2y plus 15 times the quantity of 2y minus 15. Again, this is called the difference of perfect squares. Difference, well, because there's a difference in there of perfect squares because we can square root both of them. Last one for today. All right. We have 9p squared minus 4t squared. Woo, okay. A little bit more interesting. 2 terms? Yep. 1 positive, 1 negative? Yep. Square root of this one? Well, square root of 9 is 3. Square root of p squared is p. Okay. Square root of 4 is 2. Square root of t squared is t. So we are good to go. So our first terms for each are 3p. Our second terms are 2t. one that is plus, and one that is minus. Once you get a hang of it, it goes fairly quickly. Okay, so this is one of the special patterns that I want us to be able to look for. Next week, we're going to be doing it with trinomials instead of just binomials here. That might be a little bit of a longer one, but we'll cross that bridge when we get there. I hope you all are doing well. If you have any questions at any time, feel free to email me, send me questions. I am here to help out. All right? So don't be afraid to ask. All right. You guys have a great day, and I will talk to you later.